Hello everyone. So today I'm going to talk about a very interesting branch of machine learning, which is called as reinforcement learning. We all have heard about machine learning. It is a field of study that gives computers the ability to learn and improve from experience without being explicitly programmed. It consists of three parts: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is basically where a teacher gives AI answers to form, help the AI agent and learn from it. Unsupervised learning is a type of machine learning where the algorithm learns patterns and structures from input data without explicit supervision or labeled outputs. And lastly is reinforcement learning. It is a type of machine learning where an agent learns to make decisions by trial and error in order to maximize cumulative reward. Now let's understand this with an example. Imagine you have a jar of delicious cookies sitting on top of a cabinet, just out of reach. Now there are different ways you could try to get those cookies down. First is just do random actions. You might start by randomly trying different approaches like jumping, stocking chairs, or using whatever objects you can find. Sometimes you'll succeed, sometimes you'll fail, but you learn from each attempt. Secondly, you may also try a more systematic approach. You may try one method, see if it works. If it doesn't, you adjust your strategy based on what you learned and try again. Over time, you refine your approach until you successfully grab these cookies. You might also observe others that have successfully completed taking the cookies, and you mimic their actions to your own capabilities and the specific situation that you're in. That is it. That is basically reinforcement learning. Reinforcement learning is mainly used in situations where the problem domain is complex or not fully understood. By providing rewards or penalties based on the outcomes of actions taken by an AI agent, reinforcement learning enables the agent to learn optimal behavior through trial and error. This approach allows AI systems to adapt and improve their decision-making in dynamic and uncertain environments, making it a powerful tool to tackle various real-life situations. Now let's talk about some applications of reinforcement learning. This is a famous robot that has been really famous in the recent times, and this thing actually uses reinforcement learning. Automated robots use reinforcement learning, leverage trial and error learning to navigate and perform tasks accordingly. Through interaction with their environment, these robots learn optimal actions to achieve goals, such as navigating obstacles, grasping objects, or completing specific tasks. Secondly, reinforcement learning is using games where agents make decisions by interacting with the game environment and receiving feedback in the form of rewards or penalties. Through trial and error, these agents learn optimal strategies for gameplay, such as maximizing scores, completing objectives, or outperforming the opponents. Lastly, in healthcare, by analyzing patient data and treatment outcomes, RL algorithms can recommend personalized interventions, optimize medical dosages, and assist clinicians in selecting the most effective therapies tailored to individual patient needs. This approach improves patients' outcomes, reduces treatment costs, and advances precision medical in healthcare. Now let's see how RL actually works. So this is a very famous example called grid wall example. It is one of the first things and the thing that is used to explain reinforcement learning to everyone. So let's understand this. Imagine we have a little robot on a grid. Your robot is on A and kind of a board game. A robot's buddy's goal is simple. It wants to charge its battery by finding where the charging station is. It's like being dropped into a maze without a map. So what does the robot do? It starts exploring. Just like when we're in a new place, we might wander around to see what's there. Our robot buddy tries different paths, sometimes moves left, sometimes moving right, or just to see what happens. As a robot explores, it starts to notice patterns. It realizes that certain directions tend to lead it closer to the charging station, while others lead it further away. When it moves towards the charging station, it gets positive feedback, like a pat on the back. But when it moves away, it gets like a gentle nudge to try a different approach. Here's where things get interesting. Our robot buddy is smart. It doesn't just keep doing the same thing over and over again, it learns from its experience. When it finds a path that works well, it starts to exploit that path. It's like saying, hey, moving left usually gets me close to the charging station, so I'll keep doing that. This is what a policy is in order. A policy is like set of instruction that guides an agent on what actions to take in different situations. It's kind of like a recipe for making decisions. The policy helps the agent figure out what's the best thing to do to get the most reward. Now, our robot also knows the importance of staying curious. Even when it's found a good path, it still keeps exploring from time to time. It tries out new directions to see if there might be a better way to reach the charging station. This balance between trying new things and sticking with what that works is what helps our robot buddy become a master navigator of the grid. So, as a robot buddy continues its journey, trying different moves and learning from the feedback it receives, it gradually gets better at finding the charging station and the magic of reinforcement learning in action. And that's the magic of reinforcement learning. Our robot buddy is like a little explorer discovering its way through the grid once at a time, one step at a time. Now, I'm going to demonstrate an oral agent that was made as part of one of my assignments in the courses. Uh, I'm gonna. Can you see the screen? Yeah,
Not yet.
yeah. Is this visible?
Now we can see it.
Yeah. So this is like a somewhat a grid world in which this is a game. So this is our agent, and he has to basically collect the key. This is a maze. He has to collect the key and successfully get out of the prison. So, um, if we run this, yeah. Okay, so if I run this, it'll take like 10 seconds. A little bit faster.
We're not seeing anything move. Are we supposed to see some?
Yeah, no, it's training right now, so it should go faster. Yeah, it's almost done. Once it's 100%, then it'll show something. There we go. So the agent successfully learned how to move across the grid, and it reached its destination in its perfect state without coming against these fires. So this is using oral. This is using an oral algorithm called Q learning, which is really famous and the most used one. And yeah, that was a demonstration of that. Um, and lastly, Yeah. So why is training an RL agent so hard? So that was an easy example, but in real life scenarios, it is really hard because it's like teaching a pet a new tech trick. Because let's see. So in an environment, if you keep an agent, there are very different factors that will affect it. Like suppose if you do autopilot that Tesla has, there are different things. Like there might be sometimes a road that has construction, or so basically there are a lot of ways in which you can interact the environment, which the agent has to learn every single time, and which takes a lot of data and it takes a lot of time. That's why our reinforcement learning is something that has been researched really like um researched really well and is really hard to do. But yeah, in the recent times it's getting more and more famous and people are starting to use it more and more. So yeah, that's basically a short introduction on what reinforcement learning is. Hope you liked it. Thank you.
Great, Abdul. Thanks very much for that presentation.